In this video, we will solve a problem on cost minimization. The question is, a firm wants to minimize cost of producing 40 units of output given wage rate is equal to 18 and price of capital is $2. The firm's production function given us is, which is Cobb-Douglas, which is Q is equal to K to the power 1 upon 2 times L to the power 1 upon 2. K and L denote the inputs required to produce the output. We have to find out the optimal input combinations that minimizes the cost. Okay, so what exactly we are being given? We are being given the production function is K raised power 1 upon 2 L raised power 1 upon 2. This is our Cobb-Douglas production function. Also we are being told the wage rate is equal to 18, that is W is equal to 18, and price of capital, that's denoted by R, it is being given us as 2. We need to find out the cost minimization, rather the optimal input combination is that minimizes the cost. So our endeavor will be to minimize, we want to minimize the cost. C is equal to W times L plus R times K. W denotes the wage rate, L denotes the units of labor employed, R denotes the price of capital, and K denotes the units of capital employed. Subject to the, what will be our budget constraint, production constraint, that is K raised power 1 upon 2 times L raised power 1 upon 2 should be equal to, since we are supposed to produce Q is equal to 40 units. Okay, so Q will be equal to 40 here. Okay, graphically what we want to do, we want to given our ISO count. Okay, if we denote labor on the horizontal axis, capital on the vertical axis, with the given ISO count we want to minimize the cost. Okay, so our optimal input combination will be at a point where ISO count and ISO cost lines are tangent to each other. Okay, so let us solve it using the tangency condition, that is first order condition for optimality requires that we equate the marginal rate of technical substitution between labor and capital. It should be equal to the price of labor, which is W, and upon price of capital, which is K here. Okay, so MRTS, as we know, it is equal to, MRTS is the marginal product of labor upon marginal product of capital. It should be equal to W upon K. Okay, having said that, MPL means the partial derivative of production function with respect to labor, and similarly MPK means the change in the total output with respect to the change in the units of capital employed. It should be equal to W upon R. Okay, so dQ upon dL means the partial derivative of the production function with respect to L. Let us partially differentiate this function with respect to L. Now derivative of L raised power 1 upon 2 will be, so 1 upon 2 becomes coefficient, K raised power 1 upon 2 will remain same because we are taking partials with respect to L, and the exponent of L will be subtracted by 1, so 1 upon 2 minus 1 is minus 1 upon 2, divided by dQ upon dK means the partial derivative of the given production function with respect to K this time. Okay, so the exponent of K becomes coefficient and the exponent of K is subtracted by 1, so it becomes minus 1 upon 2. L raised power 1 upon 2 will remain same. It should be equal to W upon K. W is 18, wage rate, and price of capital is 2. Okay, here we can do some cancellation, and let's do the cancellation here. These will get cancelled. Let us transpose this K to numerator and this L to denominator. That will give us K upon L will be equal to 18 upon 2 is equal to 9, which implies K is equal to 9 times L. Now we plug this value of K is equal to 9 L into the budget, rather into the production constraint. So let us see what happens here. So in place of K we write 9L. Okay, so in place of K we write 9L, so we have 9L raised power 1 upon 2 times L raised power 1 upon 2 should be equal to 40. Solving further, let me see if I have the space. I have. So 9 raised power 1 upon 2 is 3 square, so it becomes 3 L raised power 1 upon 2, L raised power 1 upon 2 bases are same. We can add the exponent, sums up to 1. So we get 3L is equal to 40, which gives us L will be equal to 40 upon 3. So L will be equal to 13.33. Similarly, to find out the value of K, so K will be equal to, the units of L is 13.33. So we have 9 times L. So 9 times 13.33. I guess it should be, K should be equal to 120. That means the units of inputs to maximize, rather to minimize cost will be, so K will be, units of capital employed will be 120 and units of labor will be equal to 13.33. I hope I make myself clear in this video. Thank you.